everyone. So our today's lead code question is lead code 3650, which is to find the minimum cost path with edge reversal. So it is a very important and very good questions to learn graphs. So what we are given is we are given a directed weighted graph having n nodes all labeled from 0 to n minus 1, and we are given an array edges which denotes that which nodes are connected to each other and their weight between these. Suppose edges of I denotes ui comma vi, means u is directed to v and having a weight w, right? And for each node we have a switch. So what this switch can do, so basically it can reverse an incoming edge to u. Suppose there is an edge from vi to ui, so using the switch we can reverse this edge and we can make it from ui to vi. And at the end, and the one more thing is, like, if we'll use the switch, suppose initially from vi to ui the weight is wi, then once we reverse the edge, its cost or weight becomes two times of the previous weight. And at the end we have to return the minimum total cost to travel from node 0 to n minus 1, and if there is no path we have to return minus 1. So if we'll see this example, here we are given four nodes 0 1 2 and 3, and there are edges that is from 0 to 1 and the weight is 3, and we have to find the path from 0 to 3 with minimum weight. So suppose if we'll go from 0 to 1, the cost is 3, and then 1 to 3, if we'll reverse this, uh, the cost will become two times of this. So 0 to 3 using this will move into using 5, and if you have to go from 0 to 2, then the cost is 2, and 2 to 3 cost is 4. So using this path the cost is 6, and using this path the cost is 3 plus 2. Why 2? Because we have reversed this as so 5, so the minimum is 5. So if you'll see the constraints, our number of nodes can be up to 5 into 10 ki power 4, as length can be up to 10 ki power 5, and and the ui and vi, that is the number of nodes, can be up to n minus 1, and weight can be up to 1000. So if we'll see, like, what will be our approach. So uh, if you know Dijkstra algorithm, so it is an algorithm that is used to find minimum distance between two nodes. So in our problem also we have to find the minimum distance from 0 to n minus 1 node. So we can use a Dijkstra algorithm here, but the thing is that here at every node we are given a switch, and that can reverse at most one incoming edge. So how we will be handling that? So what we can do is, like, instead of checking whether we have used the switch or not, what we can do is we can add a new edge, that is a reverse edge in the graph. Suppose initially edge was from x to y with cost w, so what we will do is we will add a new edge from y to x with cost two times of previous weight. So and then that reversed edge will be acting as normal edge in the Dijkstra algorithm. So basically we are transforming our graph. So original edge is from x to y with weight w, so we will be adding a reverse edge, so we don't have to check that switch is taken or not. So this will be handling. So next is, like, what is Dijkstra algorithm. So Dijkstra algorithm is basically used to find shortest path between a source and destination. It will not work if negative weights or negative cycles are present in the graph. So in this, what we do is we will be using a min heap, and in that min heap we will be storing our distance and start node, and then we take out the node with the shortest distance. Min heap will be returning as the node with the shortest distance. So we take the node with the shortest distance, and then what we do is we will find all the adjacent nodes of the node that we have taken, and then check if the distance that is to reach the current node is less than the already present distance, means already what we call reached distance. If yes, then what we do is we will be updating and push the it in the min heap else leave. So we will be seeing with this an example. So we are given a graph that has like this graph. So initially assuming source is equal to 0. So initially distance, all distances are infinite. 0 to means 0 to 0, and all distances are infinite. So what we do is we will be putting distance comma start in min heap. So our start is 0, and distance of our start, that is 0 from source is 0. So from 0 to 0 distance is 0. So we will put 0 comma 0 in the min heap, and we will update the distance of 0 as 0, and min heap will be looking like this. Then we will take the top element from the min heap. So only one element is present, so we'll be taking this. So distance equal to 0, node equal to 0. Then we'll be checking all the adjacent nodes of 0. So all the adjacent nodes of 0 are 1 and 2 with distance 4. So distance from 0 to 2 is 4. And what is current distance, what is the current distance of 2 in the array? So current distance of 2 is infinite. And but if we'll take this path, that is 0 to 2, our distance is 4, means our this distance, that is 4, is less than infinite. So we can update the distance of node 2 and push it in the minimum heap. So if we'll see the distance array, we have updated distance of 2 to 4 and push it in the minimum heap, that is 4 comma 2. Same way we'll be doing from 0 to 1. We have updated its distance to 4, and it puts also it in the min heap. Now if we'll again take the next element, top element, so if we'll see distance for both is 4 4, then we'll check the which is the smaller node. So we'll be taking 4 comma 1. So distance comma node, so distance is 4, node is 1. So adjacent nodes to 1 are 0 and 2. So if we'll check, if we'll go from 1 to 0, our edge weight is 4. So total distance is current distance, that is 4 plus edge weight. So total distance is 8, but distance of 0 is already 0 in the distance array. So that is less than the distance that we get one if we'll go from 1 to 0. So we will not be updating it. And then 1 to 2, suppose if we'll go from 1 to 2, so 1 to 2 the edge weight is 2. So total distance is the current distance, that is 4, and the edge weight, that is 6. So but distance of 2 in the array is 4, which is less than 6, so we won't be updating it. So if we'll see the code part here, what we'll do is initially we will make our graph. In the graph we'll be pushing our normal edges and our reversed edges, and then we will be using uh, this distance array to store all the distances, and then visited, and then using priority queue, that is min heap. So initially distance of 0 is equal to 0 because this is our source node and starting node. Then we'll be pushing that distance comma node in the this min heap, and we'll be using this loop until our min heap node becomes empty. So we will be taking the node pq.top.second will be returning our node with the minimum distance, and if our node is equal to the node that we require, that is our n minus 1 node, destination node, then we will be returning directly distance of u, that distance that we have till now. And if it is already visited, then we won't be taking it in consideration, else we will mark it visited and check all its adjacent nodes. Suppose if we won't be able to return, if we want to be able to return reach to the n minus 1 node, then in that case we will be returning minus 1. That's it. Thank you. I hope you liked this video. So please make sure to like and share, subscribe the channel. Thank you.